return the element at position front, right? Correct? So we should say En equal Q at position front. Not 0, because remember, 0 is not always the front. It can move, that's why we're doing all that work. Remember? That's why we keep track of front. Now, we have to return this element N, right? We have to decrement size, right? Then we have to make front plus. Because this is front and I is Q, now this is front. But what's the problem? Again, we have a similar problem. If this is the stack, and this is my element, right? This is front. And here's the other element. For example, 0, 1, 2. And I DQ this should be my new front. If I make front plus plus, I will say 3. That's not correct. So what can I do? Mod capacity. And that will make me move front to the next, right? So I will say front equal front plus 1 mod capacity. Now we're called stack. Which one do you like better? Stacks or queues? This round thing makes it complicated in queues, right? That's all. Now, if we were to use linked list instead of arrays, if you want a DQ, head next. Done. Right? If you want an NQ, at last, because it always goes at the end in a queue. Done. Right? If you're using stacks with linked list, how do you push? At first. How do you pop? You just get ahead all the time, because that's the last one you insert. That's it. Right? Just make sure you keep track of size and all that. Okay, guys. One little exercise just to warm up. The next class we're going to do one. Okay? How could you implement a queue with two stacks? This question. How do you implement a queue with two stacks? If you implement a queue with one stack, it is impossible. Because if you insert elements into this stack, then if you want to remove them, you say the queue, you're going to get them in reverse order. Right? Correct? But if we have two stacks, it's simple. You put them in reverse order here, and then you pop them up and put them here now. Now, here are in the order that they were inserted. You pop, and it's behaving like a queue. How hard is that? Nothing, right? Okay. See, we have more of queues somewhere here. Okay, same thing as before. Easy question, but now you play with a queue. So try to put in the queue and DQ and see how it looks. Simple, right? So you should have EAS, and then you say DQ, right? You take the E, not the S, the E, right? Because D was inserted first. Got it? We played like this with the stacks. Now play like that with queues. Same idea. When we had the stacks, and this meant pop, then you had to pop yes, because that was the last insertion. But now when you say D has to go, because that was the one that was inserted first. Right? You can always Google this, guys. You saw how to Google this Princeton website, right? Princeton stack exercises. The first link will take you where you want. Okay? Very easy, right? How many classes do we have left, by the way? Two more?
Three, sorry.
Three?
Wednesday and next week.
So Wednesday I'll do maybe a little bit more of queues. Then I'm pretty much covered with the main thing from Java 2. We move fast, it's good. I'm pretty much done with the most core of Java 2. The rest are like introductions to collections. I'll give you a little bit of that. I'm not going to evaluate you on that, so don't worry about it. I'll give you maybe a little bit of GUI, maybe. And with that, I think the semester is done. We have been able to cover most of the most important things.